All right, folks, we are going to get things going here for the second part of the afternoon, and a great big thank you to TD Canada Trust Agriculture Services and Visit Moose Jaw for the snack break here this afternoon. Are we having a good time this afternoon? Are we learning lots? We're learning lots? Good to hear. I'm glad. We're going to jump back into things here. Our next presenter is Dr. Greg Penner, professor at the University of Things here. Our next presenter is Dr. Greg Penner, professor at the University of Saskatchewan, and he's going to be providing an update on his research to identify forage-efficient cattle. Dr. Greg Penner is a professor at the Department of Animal and Poultry Science. He holds a Centennial Enhancement Chair in Ruminant Nutritional Physiology at the University of Saskatchewan. He was hired in 2009 after obtaining his bachelor's degree from 2004 and his master's degree at the University of Saskatchewan, his PhD from the University of Alberta, that was in 2009. His team focuses on forage from the university, or from forage utilization, beef and dairy cattle nutrition, and regulation of gastrointestinal function in ruminants. I do the same thing in my spare time. Greg is actively involved in teaching at the undergraduate and graduate levels within the Animal Science program at the College of Agriculture and Bioresources. As part of his outreach, Dr. Penner participates as an organizing committee member for the Saskatchewan Beef Industry Conference and the Saskatchewan Pasture Tour. Our presentation today is brought to you by the Saskatchewan Stock Growers Foundation. Please welcome Dr. Penner.
Thank you. I'm really excited to be here. It's been a couple years since I've been at the SSGA meeting, and I really am excited about the work we're going to show you. I think this is something that I hope you can apply on your ranch immediately if you see value, and I look forward to discussion regarding our approach. I want to also recognize Justin Delver. Justin Delver just finished his master's in my program, came out of a cow-calf operation out of Fort Macleod, Alberta, and is off to do his PhD in South Dakota. Fantastic student that did a lot of great work. The other people I need to mention, first of all, this project is really grassroots driven. And so we had conversations with Dwayne and Ross, and Dwayne and Ross were really challenging us on whether we can develop a different efficiency metric to characterize values that would be appropriate for the cow-calf industry. And so we'll talk about that a little bit more. And then we also have collaboration from Dr. Bart Lardner, Dr. Mika Sai-Coquel, Dr. Matthew Links, John McKinnon, and Gabrielle Ribeiro. So a cast of 1,000, but everybody had an active role, and I think it helped make this project quite a bit stronger. So if we think about efficiency in cow-calf systems, we have some challenges to deal with. Most of the efficiency approaches that are available are based on intake and gain. And obviously in a mature cow, we're not really looking to maximize, and in many cases not looking to actually add gain. So these metrics become very challenging. It's also really difficult to quantify feed intake, and so metrics that are based on feed intake aren't going to be very easy to adopt on a cow-calf system. The other aspect is if we move those cows into artificial conditions to measure intake, we've now removed that cow from an environment reflective of what she is designed to live in. And so again, these metrics that rely on intake measurement really challenge the ability to characterize it for the cow-calf sector. Probably the most important is that if we just focus on gain and feed intake, we're ignoring the profit centers for the cow-calf sector. Okay, so while gain to feed makes sense from a feedlot perspective because the gain is what is being sold, the input cost of feed is being recognized, on a cow-calf sector, there's no revenue on the cow side from gain except the high cull cow prices that Brenna was talking about, and that's not going to help us from an industry sustainability perspective long term. So we were really looking for metrics that were better representative or more representative indicators for efficiency in the cow herd. So we went back and we started reading the rancher's contract. How many of you have a contract with your cows? I'm sure you all do, whether it's written or not, right? I think most ranchers are looking for those cows to maintain body condition score in the environment and management conditions that they're housed in. Okay, this is one of the expectations that we have of our cows, to fit the production system that we're imposing, and every year you are selecting heifers that do a better job of fitting that production system. We want those cows to breed early in the breeding season each year, and that allows them to calve early in the calving season each year. That gives the calf more days of growth, that gives the cow more days to recover from calving and be more likely to calve the next year, or breed and then calve the next year. And then we want a cow to wean a heavy calf. And notice in the brackets, we want that calf to be heavy relative to the weight of the cow. And so we're not talking about the highest market weight for a calf, because that starts impacting breed selection. We're looking again for a high percentage of body weight relative to the calf weight. And we're going to adjust that depending on whether we're having a heifer calf or a steer calf. Okay, because we know that those body weights are going to be different. So considering that rancher's contract, what we wanted to do is decide if we could design an efficiency or a productivity metric-based system around these factors. And so that was our focus of this study. And so working with Dr. Bart Lardner out at the Western Beef Development Center, that's how old this project was when we initiated. It's quite a long-term study. We selected 100 first calf heifers. So these were heifers, yearling heifers going into their first breeding season. We evaluated them over the next 2 calving seasons so that we could have rump fat thickness at the time of calving. And we'll talk about why we did that. And we gave that a maximum of 10 points. So our view was the ability of those heifers and finally cows to maintain back fat thickness during the winter breeding period allowed us to assess whether they were coping with the environment and the management conditions. Because that was a direct effect of the heifer, we gave it the highest ranking. So we ranked them out of 10 in a percentile basis. The next criteria was calving date in the calving season, and the reason we gave it a lower ranking was because their ability to maintain body condition score, or rump fat thickness, would influence their ability to rebreed. And so we didn't want to be double accounting for rump fat thickness. Calving date could also be influenced by the sire, or whether the sire was functional. And so we didn't want to discount the cow more or equally to back fat thickness because it might be outside of her control. Finally, sex-based calf weaning weight, and so that would be heifer versus steer. Again, the weaning weight of the calf is influenced by the cow, but it's influenced less directly. And so there's other factors that could influence the rate of growth, and you just heard Dwayne talk about canola meal supplementation, and I know he was talking about yearlings, but let's not forget these very young calves have a much higher nutrient requirement, and as those cows are starting to dry off, there's a need for those calves. So calves that grow under better quality pasture conditions are going to gain more weight than those that have senesced pastures to graze. The other important part is we wanted to heavily penalize cows that did not produce a calf. So even though the maximum score was 6 for calf weaning weight or 8 for calving date, if they didn't produce a calf, they were deducted 2 points. So they got an immediate and quite severe penalty within our ranking system. Okay, so we ranked those heifers in the first year, and then we ranked them as first calf cows in the second year, and we ranked them independently. So this is just an example of our scoring system. And under our extensive managed system out at Western Beef, we didn't have a problem with fat cows. And so our cows that contained the highest back fat thickness actually got the highest score. And you can see we don't always have the top end of the score given to individual cows because we did this on a percentile system. So if multiple cows have the same value, we split the score across those multiple cows. Okay, the other side I want to show you is calf weaning weight, and we rank them independently when they were steers or heifers, recognizing steers are going to be heavier. And you can see between year 1 and year 2, we have different steer weights as a percentage of body weight, right? They were first calf heifers in year 1. They were second calf cows in year 2, so they are still growing. And the calf, at least in year 2, didn't grow as much as the cow body weight increased, hence the lower percentage of calf weight as a function of cow weight. So the point is we can see that we have a scoring system, and the scoring system is allowing us to rank those cows based on productivity metrics that we viewed as being important and critical. First thing we recognized is that a single year ranking system probably will not pick out the cows that fit that efficiency ranking over a longer period of time. So I think we really need multiple years of data to make sure that we are consistently picking out cows. And I can tell you with many ranking systems, it's highly probable that cows re-rank. And this is a real strong problem for residual feed intake, or RFI, where the re-ranking proportion is about 43%. Okay, so it's not uncommon for efficiency systems to require multiple measurements to obtain confidence in their outcome. Point is, we can pick out cows that are highly efficient in both years. So if you look at the upper right quadrant, the area highlighted in green or blue, however your eyes see it, those are our cows that are consistently efficient in year 1 and year 2. And those that are least efficient are shown in the bottom left quadrant, highlighted in that yellow or orange circle. The other aspect is there was only a weak correlation across years and across traits. So even though we were worried about that autocorrelation, what it really told us is these traits are independent enough that they're not strongly influencing each other. So again, that bodes well to our efficiency metric. I want to highlight that our system was successful. Okay, so if we look at rump fat thickness, and now we've taken our index, we've selected the 9 best and the 9 worst, we can see that the 9 best, the high efficient, shown in green, had a thicker rump fat at the time of calving. They calved earlier in the calving season, so the average was around day 14 and a half relative to the start of the calving season versus almost day 30 relative to the start of the calving season. So those efficient animals are calving early, and that makes sense because that was part of our ranking metric. And probably what matters here from a revenue side is when we look at sex-adjusted calf weight, we have about 44 pounds more calf from our high efficient than we do from our low efficient. So this is not saying all of our cows are going to produce 44 more pounds of calf, but hopefully this gives us a tool so that we can start creeping up the whole herd to become more productive. And we'll talk about what that means from a feed resource and how those cows were using those feed resources. But my point here is we're able to effectively rank the cows, and by ranking the cows, we are actually selecting animals that are more productive from a revenue perspective on a cow-calf based scenario. So Brenna, multiply that by the number of, or the amount of value per pound, well over $2 now. So if you look at that, if we can creep them closer, at least in this comparison, we're probably $90 to $120 a cow more because of selecting for those more efficient animals. Okay, so we can select cows, and what I want you to recognize is this ranking system did not pay any attention to what was happening to feed intake and digestibility. Okay, so that's really what we wanted to do in the next step. So the next phase, once we identified these cows, was to start understanding how and why they differed in terms of efficiency. Okay, and we wanted to address some challenges that other efficiency systems have. Gain to feed, as an example, is influenced by the energy content of the diet, right? We know higher energy contents will drive more gain per unit of feed. Residual feed intake causes cows to re-rank based on the energy content of the diet. And so we wanted to make sure that our ranking system was not going to be biased, or test whether our ranking system was biased by the quality of the diet. So I'm not going to go into the diets in detail. The whole point is we went from a pretty high quality diet to a diet that was straw-based. So 50% of the diet dry matter was wheat straw. So a pretty low quality diet that was really designed just to meet the energy requirements of these cows. All the cows were fed all the diets in the same sequence and at the same time, so we don't have any diet effects. And really what we were trying to understand is if those cows are going to perform different based on their ranking system and the diet quality. So just like we saw in the field, when we brought those cows into the barn, we fit them with rumen cannulas so that we could get into the rumen. And we went through our in-barn metabolism study. And just like we saw in the field, those cows that maintained a higher rump fat thickness in the field had higher rump fat thickness and actually gained more rump fat during the metabolism study. So we're measuring a variable under two very different conditions, but we're getting the same effect based on our efficiency ranking. Okay, we also saw these high efficiency cows were actually lighter, and statistically lighter. This again was not part of our selection criteria, right? We were allowing the cows to tell us which ones are better performers based on calf body weight as a function of cow weight, but we found that those more efficient cows were actually had lighter body weights than the less efficient cows. Okay, so important to recognize that we have similar results in the barn as we do in the field. We've inadvertently selected for somewhat lighter cows that have an ability to maintain their back fat thickness. Now, when we looked at feed consumption, and feed is really important considering the cost, but what we found is high efficient and low efficient cows actually ate the same amount when we think about it in kilos per day. But because those high efficient cows were lighter, they ate more as a percentage of body weight. Okay, so the grocery bill shouldn't change, right, per cow because the number of kilos being consumed are the same, but we know those cows are smaller and so they're eating more as a function of body weight. Okay, so the other aspect is the intake response did not differ by diet. So I'm not going to show you any of the diet responses simply because the efficiency ranking did not change with the diet system. So we have a stable efficiency system independent of dietary quality. We're able to go quite deep inside these cows. Obviously, they're ruminally cannulated, and so we can try to understand why they're able to eat more as a percentage of body weight, given that they were lighter. And one of the things we looked at is rumen contractions. And contractions are really important to make sure that there's mixing in the rumen, to pass out that indigestible material and make sure that the bugs inside the rumen have access to bind to that feed and digest it. And we found a result that initially was a little surprising, at least to us, where those low efficient cows actually had higher contraction force and contraction strength. So it looked to us like those low efficient cows actually had what would be assumed to be a more efficient rumen. But as we started looking into the data and thinking about it more, we found what we think is a reason for this, and I think it helps to explain that efficiency ranking. First thing I want to do, again, maybe because I'm at the university, is make sure you understand how fiber moves through the rumen. Okay, and so if we look inside the rumen, we can see at the top of the rumen is going to be the gas cap. Right? If the gas cap gets too big, the cows bloat, right? We need those cows to eructate and remove that carbon dioxide and remove that methane. Below the rumen, or the gas cap, we have the rumen mat. And this is the bulk fill where that fiber is going to float on the liquid, and that's where most of the digesta mass is going to be. So when cows are consuming straw, that that rumen mat actually becomes quite big, and those cows need to have those contractions to make sure they can regurgitate that fiber, chew it, to break it up into smaller pieces so that the microbes can digest it, or it can pass out of the rumen. Okay? And then below that, we have a liquid phase. And the liquid phase is what carries the material out of the rumen. Okay? All the small particles will be in the liquid phase as they flow out of the rumen. So if we're going to have clearance of fiber out of the rumen, we need those long particles to be reduced in their particle size through chewing primarily, but also through digestion. And we want that digestion to occur because that's how the cows get energy from forage. Okay? And then we want those fibers to pass out of the rumen because there's indigestible components of the fiber that just takes up bulk space, and we don't want it sitting in the rumen too long, or the cows aren't consuming more nutrients. Okay, and what we were able to show is that the high-efficiency cows actually had a smaller rumen digesta mass. And I'm going to show this is both on an as-is, so a wet basis, but also on a dry basis. And when we looked at this, they also contained less fiber in the rumen and less undegradable fiber. So you'll see a new term called UNDF. That's the undigestible fiber that the cows consume. Okay, they all consume fiber, and part of that fiber is not digestible. No matter how long it would sit in the rumen, it's not digestible. So remember that these high-efficient cows ate the same number of kilos, but somehow they had less fiber in the rumen, and they actually had less undigestible fiber in the rumen without differences in diet selection. And really what they were able to do is accelerate the passage of that undigestible fiber out of the rumen faster. So somehow these high-efficient cows are able to digest what's available and kick that undigested material out of the rumen at a greater rate. And that's really important because that undigested material, even if it sat in the cow's rumen for 10 or 20 days, would not be digested. So it's just occupying space. Okay, and that's really important to think of because if you look at the weights on the left-hand side, these cows are walking with 70 to almost 80 kilos of digesta. So 150 to 170 kilos in the digesta of a rumen of a cow walking around under normal conditions. The faster those cows can cycle that weight through them, the greater the ability they have to extract nutrients from that poor quality feed. Again, that was not affected by diet. So it didn't matter if we were feeding a high quality silage or feeding a diet that was 50% wheat straw. We saw the exact same effect based on our efficiency ranking. If material passes out faster, we often think we'll have reduced digestibility. But we didn't see any reduction in digestibility. And that points out that they were passing out undigestible material rather than digestible material. So really what's happening is these high-efficient cows have the ability to digest the available fiber, kick out the undigestible fiber faster, so that they can eat more as a function of body weight. Okay? I think that's exactly what we want to happen for these cows that are fed poor quality or low quality opportunity feeds, particularly during our winter feeding or grazing system. So our conclusions. If we rank cows based on back fat thickness, calving date, calf weaning weight, we can use those metrics within our ranking system to identify efficient cows within your herd. Okay, I hope you're recognizing that the technology required to do this is really not limiting, right? And we'll talk about that a little bit in the next slide. Our major findings are that those efficient cows produced more calf but did not require more groceries. So we're increasing revenue potential without increasing feed cost. That's an important feed efficiency metric for the cow-calf systems. Okay, so they're eating more as a percentage of body weight, but not for total intake. They gained more body condition score during our study, both in the barn and outside of the barn. And we think they were able to do this by retaining less solid material in the rumen because they had a greater passage of that undigestible material. So they didn't try to waste time digesting every morsel of fiber. They kicked out that undigested material faster. And they did that without compromising dietary digestibility. Okay, so we're really looking at a system that allows to identify cows that are locally adapted to a production system, those cows that are going to perform well year in and year out. So how do we apply this? Again, everybody has the ability to measure body condition score. So we used ultrasound to measure back fat thickness because we wanted a quantitative measurement. But everyone has the ability, and there are numerous extension articles on how to measure body condition score of the cows. Okay, what are we asking you to do if you want to adopt this approach? Write down the measurement, your assessment for each cow. The key to this approach is record management and record review. Okay? None of the records we're talking about are really very challenging. The other thing we need is to know when those cows are calving. Okay, so we don't need the hour, a day or 2 or 3 day window probably is sufficient enough in terms of sensitivity to pick out those cows that are calving early in the calving season. Okay, so even under larger scale operations, we should be able to predict or determine when those cows are calving. It's pretty important because that's our key indicator of reproductive fitness. Okay, those cows that calve early are more likely to stay within the herd, more likely to produce a heavier calf because that calf has more days to grow if you market them all at the same day. Finally, we need a scale. Okay, and there's many benefits to a scale besides this efficiency index. But if we can correct the calf weight for cow age, again, we don't want to penalize heifers relative to mature cows. We need to be able to represent that calf weight as a function of the cow weight to make sure that cow is doing her job relative to the inputs that she requires, and to correct it for calf sex, knowing that steers are going to grow, on average, faster than heifers. Okay, and the tools to do this are, again, widely available. The other side of this is Justin, coming from a cow-calf operation, really wanted an applied tool, and we've developed an Excel-based macro that allows you to enter your cows and the inputs, and it will calculate your forage efficiency index based on your own values. We're trying to make that spreadsheet a little more user-friendly, and hopefully in the very near future, we'll have some updates and we'll be releasing that program. With that, I'd like to again thank our producer collaborators. Without them, we probably would have not delved into this area. Also have to thank again Justin Delver for the hours he put in and the dedication to this project, and our funding associations, the Saskatchewan Cattlemen's Association through the Industry Development Fund, as well as the provincial government through the Agriculture Development Fund and the Canada-Saskatchewan Growing Forward 2 bilateral agreement. With that, I'd be happy to address any questions or challenges you might have, and I hope there's something in there that you can take back to your ranch.
Dr. Greg Penner, thank you very much. Is there any questions that we have for Dr. Penner here this afternoon? Now, forgive me if you mentioned this, but did you note what type of cattle?
I think that's one of the strengths with our system. So in our approach, we had a Black Angus-based herd. That's because that's what the university herd is. I don't think the breed matters. In this case, we're trying to use metrics that are appropriate for every cow-calf operation, irrespective of the breed. And those 3 variables that I mentioned in the rancher's contract, it doesn't matter if you're in Brazil or in Pontiac, Saskatchewan, those 3 variables impact your profitability. And so I don't think breed will drive the response. I also think that will prevent you from having an EPD for this type of characteristic. This is a maternal selection characteristic.
I have a couple of questions here. First off, we'll start with you here on my right.
Hello
Your name.
there. Thanks, Greg, for the presentation. Marianne Posper from Sask Cattlemen's. I'm really interested to hear what you think you want to do next in this area. And also if you can talk what you think you want to do next in this area. And also if you can talk a little bit about the economics as well and how big of a play that's going to make on this project.
Yeah, great questions, Marianne. So from my perspective, I'm really now a supporter on this project. So Dr. Mika Asai-Cokwell is a geneticist. Genes that have shown very strong responses that might help us better predict which cows, and maybe that extends this into the sire response. I think we have to be careful with the results we have so far because they are genes that are associated with the selection within one herd, within one breed. And so we need to have a broader scale application where we expand this so that we can look and verify whether these candidate genes actually fit within multiple herds. The benefit there is we can extend this feed efficiency ranking to the sire. Okay? I think the benefit of this project is it can be adopted immediately on cow-calf operations with those 3 limitations of data. In terms of the economics, that's variable by year, right? The exciting part is it didn't look like the grocery bill was going to be affected, but the revenue side of the equation looks to be strongly improved. The magnitude of that is accentuated in our research because we picked the top and the bottom, right? So I'm not saying you're going to see 44 pounds if you do this on a herd level. It's going to be more modest. But recognize there is a huge range in productivity among cows within a herd. And if we can start identifying a system to select more for those genetics or those cows, the behaviors that are causing them to be successful in our system, we have a higher ability to have more revenue generated per cow.
We only have time for one more question, and this gentleman over here, your name, please? There should be an on button on the top. There should be just a switch on the top there.
If you yell, Mark, I can hear you and repeat it.
Okay, yeah. There's only time for one question. And first, I want to say thanks for doing this kind of research. So I'll ask my question in 2 parts. And first of all, you used a couple of words interchangeably there, and I'd like to just hear you clarify a little bit on smaller. And there was 2 words, smaller. And what was the other one you were using? And lighter. I'd like you to comment on that. And have you done any work on did you extrapolate that information out as far as how many pounds of grass, for example, when they were on a forage diet, that you would harvest with the cows that you wanted to select as your herd as opposed to the other ones? So those are my question in 2 parts. Thank you.
Great questions, and you're schooling me here, Mark. You're right. I should not use smaller and lighter as synonyms. They are not the same. What we measured is weight. So they were lighter without being lower in condition. Okay, so we did not measure frame size. I can't tell you if they were shorter or other terms that would describe a smaller animal, but they were lighter in terms of body weight. Did we extrapolate the amount of grass that would be required? No, we didn't, but and I apologize if my translation or assumption is maybe not what you're thinking of. Because dry matter intake did not differ between groups, we're making the assumption that the efficiency ranking will not affect forage requirements. Okay, the cows were lighter. I almost did it again. Cows were lighter and they ate more as a percentage of body weight, but the total kilos required did not differ. So I don't think it's going to affect pasture requirements.
Thank you very much. Garner Diebold has a special presentation for you. And ladies and gentlemen, Dr. Greg Penner, thank you very much. This was sponsored by the Saskatchewan Stock Growers Foundation.